Hey guys, welcome to the shop. So today we're going to be talking about grinding these blocks in closer to square. As of now, we have them within 6/10,000ths of an inch. So an explanation of squareness is effectively over here we see how close to 90 degrees each of these corners are. Now, to some degree or another, everything is going to lean one way or lean another. It's always going to have a slight rhombic shape. There's no such thing as a perfect 90-degree corner. And as we're assessing squareness, it's 1/2 of the difference between your high and your low reading. Now, your high and your low reading is a measure of how far it's leaning one way or the other. And there's two ways to do it. I do it this way, which is I just direct read in 10,000ths of an inch, subtract the difference and measure it, and assume it's leaning towards your high side. And what you can also do if you want to do it quicker is you can zero the difference between these, i.e. add 6/10,000ths to your low, so perfectly square on this indicator would be reading 3.2 thousandths of an inch. Now there's a couple ways to do it. If you're okay with a couple thousandths, you can actually just use a precision square like this. This will get you to within 1/1000th of an inch, but it's not as ideal as a grinder and a surface plate and some more meticulous inspection. Now, one method, and this is just a method that works if you don't have sufficient shim stock, is it's called grinding a shim. So this part leans this way. Now what I'm going to do and flip it over and it leans towards this side is I'm going to grind a height differential in here till I'm very close to the edge, a 1/16th of an inch at most. And then when you flip it back over, you assume that by grinding that shim in, now you've corrected that lean, so it's averaging out the lean this way. Alternatively, you can use receipt paper, or you can see the chunk I've already taken out of this manual. Now, this paper is about 3/1000ths or 4/1000ths of an inch thick. It works out to shim very close to 3/1000ths of an inch once it's compressed by the mag chuck. This is good for about 1.5 thousandths of correction. Some of the cheaper rolling papers are actually pretty good shim stock, and I do not smoke rollies or partake in the devil's lettuce, so those don't really show up in my shop often. So I tend to just refer to this grinding in a shim. It's also it's also technically called step grinding, I think, because there's a step here. I can illustrate it on one of these parts. I've already done this on the grinder, and you also see I haven't fully cleaned up this face because this is over length by quite a bit, because the goal was to grind them square. Now, I'm not a great grinder hand, so I try to give myself between 20 to 80 thousandths of an inch to correct for. I'd rather take extra time making it perfect than have to remake the whole part. But effectively, if we assume the part leans this way, that means this corner here is low. What I can do is flip the part over, and I just like to mark it with Sharpie and grind off all of this unmarked material here. So when you flip it back over, you've effectively made it lean that way by whatever the height differential is between here and here. Now that works very well and it's very repeatable, but you need to use a surface plate to figure out your exact lean. And it's also what's convenient is I've noticed it averages out on these two faces too. So off the mill, what I have noticed is typically 4 of your faces are squarer than the others. So I correct those and get those 4 good faces first. And then the other 2 easy faces, if you have a good grinding vise, all you need to do is clamp it in the vise. But what also works is you can, again, grind a shim if you're sufficiently oversized. Grinding vise, you don't need as much room for correction because you just make the assumption once it's clamped in here, it's going to be square. Now, I am working on a grinding vise project very slowly. I think what'll happen is I might actually buy one because it'll make it easier to make the next one. But one limitation of this particular grinding method is that it works extremely poorly on round stock. Now, if you want to use this grinding method on round stock, you should take the mill, and you need enough room to do this. Take the mill and just square it. Give yourself a square surface to rest on and, mill this 50 or 80 thousandths of an inch deep. You still get some rolling in this corner here, but you would ideally make it perfectly square. Or rectangle works. It doesn't really matter if it's rectangular or square, just because you don't want it rolling where if I have a height differential here, the part tends to do this, and it can be pretty unpredictable. So in this case, you either need a really precise fixture, or again, you just make the part over length, mill it square, and then you can use the step grinding method. So that's just a little bit of an aside. And over on the surface plate here, it is probably hard to read the indicator, but we can see our high. We're looking for our high reading now. Our high reading was 32. And our high reading was 35. So that's actually really square. That puts it at 1.5 10,000ths of an inch off. We'll see what this side is. One of the issues is this particular setup is not as repeatable as I would like. So there we are, 16. And we'll call that 48. So the difference between 16 and 48 is 32. So that is 1.6 thousandths of an inch off. So since we're leaning this way, we need to leave a high side here. And I tend to just reference one side the whole time. So this is going to go down on the magnetic chuck this way. And what we can do is we can check, actually, it might be more square this way. It might be way farther off. Yeah, so this face is in way worse shape because there's a burr on it, and I did not notice that burr. That's also another thing. If you get a crazy reading, check for dirt on the plate and check for burrs. Because a lot of the time, you don't have to deburr as aggressively when you're grinding, but it is good to check. Don't make the assumption that everything's clean and deburred, even though you did clean and deburr it, because you can miss a face just like that. Now let's check again and see what this is. See how much better that was? So that was 46 minus 22. So that's 1/1000th of an inch off, not 2.5 thousandths. Now we're going to just jump over to the grinder really quick. I will turn it on, warm it up, and then start filming once we're ready to go. So I'm just going to pop my respirator off now so you can hear me. But what we're going to do now is prove that this step we ground in, focus, we're going to prove that this step we ground in improved the situation, and if it didn't, we're going to correct it. $25. And we got 38. So 13 over 2 is 6.5 10,000ths of an inch. I don't have the resolution in my machines to fully correct for that. So what we're going to do is we're going to flip this part over and grind the top side. And I don't think you guys need to watch the exact same operation twice. It looks the same. Grinding the Sparkies look really cool and they're fun, but you can only watch it for so long before it gets tedious. So we're back at the surface plate. We tickled this guy in, and let's hope we're kind of square. So our high reading was between 34 and 35 tenths. And our low reading was like 31. So I am going to call that square. Let's check our other face, because now we're going to tickle in the other face. $24, $25. And about 3. Okay, so that's really good. This block is square to within 2 10,000ths of an inch on this face at that height. Now, one of the assumptions we cannot make is that both faces are square. Now, what we're going to do now is just, again, compare. This is called a comparator. Now, there's actually a tool called a Square Master where you can move the indicator up and down so you can run this face. We don't have Square Master money in this shop. All right, so we got 29. $35, pretty good, about 3 tenths. Got 4 thousandths, so 40. $28. So okay, so on our worst face, we're 0.5 thousandths. We're leaning a little bit less than 0.5 thousandths this way. On my grinder, the hand wheels are graduated in 1/2 thousandths of an inch increments for my down feed. So for something like this, if I'm within 0.5 thou, I kind of just say that's good enough. I don't really want to go crazy with it, because what we still haven't done is height matched these. You can feel they're not quite the same height. So we're going to have to go back on the grinder and height match them. And I think our target length, I decided, was 2.5 or 2.6 inches. So let's see what they actually are. Oh, we're bang on this guy, 2.5 inches. See, we're about 0.5 thou under on there. About 1 thou high here. This one needed a lot less squaring work, so I assume we're a bit taller. So we got 5 thousandths to go. And about 5 thousandths to go. So I'm just going to knock the top of these guys off, call them square, and then we can go on to the drilling and tapping in the next video. Now, if you're interested, I'm just going to leave 5 or 10 minutes of rough grinding after this. Otherwise, you can consider this the real end to the video, at least the informational content. So thanks for watching, guys. I hope you enjoyed. So I totally lied about that being the end of the informational content. That's kind of the end of the main informational content. But I think it might be interesting for those of you who are watching this long to get an understanding of what I'm doing. Now, that tool in the video that's attached to the magnetic chuck, that's called a dressing tool. That's just a single point diamond tool. You use that to clean the wheel and expose fresh abrasive so it's not all chewy and loaded up, and you get a better surface finish and the wheel runs cooler. You have to clean the chuck before you put your parts down. I like to use my hand because you can feel really, really small material on there very easily. And if you're not sure, just keep wiping. So I just put the blocks on there, one of the blocks on there, and I wiped the other one off. It didn't feel right going on the plate, mag chuck, so yeah, you see I cut a bird there. If you're not sure, keep cleaning. So you just knock them off the file. Doesn't need to be complicated. I mean, people buy the fancy pants deburring tools, but I use chainsaw depth gauge files. They last a really long time, and you can use them for other stuff too. And again, if you're not sure if it's clean enough or deburred well enough, it isn't. You cannot keep anything too clean for this. You know, parallelism's a lot easier to grind for than squareness, and you will also watch me bumble my way into the material. I touch off way too hard, and I think I'm taking a 3,000th depth of cut, which on a surface grinder is a lot of material to remove. Not the end of the world, and the reason I did that is because frankly I didn't want to bend over and stick my head under the camera and look straight at the white wall, so it can be really easy to see half a thousandths or even, yep, rammed it right in there. See, that's a real heavy cut. So what we do to get around that is just a very slow cross feed. So this is sort of, people call it peel grinding because you're peeling away the top of the surface. You're only cutting with one corner of the wheel. If you're familiar with how a train wheel basically wears into a cone, that's what these wheels do. So on a manual grinder, especially one like this where it's difficult to dress and pick back up where you were, a lot of the big, more commercially oriented production grinders actually have a dressing wheel or dressing tool integrated into the wheel guard. And you can take off a prescribed amount and lower the wheel by that amount. Now, unfortunately, I don't have that, so I have to dress the way you saw. And that slows you down a lot. It's not very convenient, and it makes it hard to pick up back where you were. So I like to get through at whatever face that whole total area in one dressing on the wheel. And what I'm doing here is called sparking out, where the oil film and the bearings will deflect under load. So I'm bringing the wheel down actually about half of one of my graduations, so about 2 or 3 10,000ths of an inch to just clean everything up and get a good finish on it. And this worked pretty well. Overall, the finish is sufficient for the task. We're sufficiently square. There's a little more grinding that needs to be done to bring everything into dimension before we start drilling and tapping, but overall not much. And it's going to look exactly the same as this. This is a much more explanation heavy video because everything looks the same on a grinder even when you're doing something very different. So thanks for watching, guys. I really appreciate those of you who made it this far into the video, and it's always a pleasure getting to share this stuff with you.